Hello, I'm James Sylvester from JPS Reliability and the Reliability Training Institute RMS. And what we're sharing with you today is case study 3 of 5. As with the previous 2 case studies, we're going to discuss the failure cause, the failure mechanism, and the failure mode. And as with the 2 case studies previously, this is from real life data. And it's another example from my book, Enhancing System Reliability Through Vibration Technology, which was recently published. In addition, again, it's working with the Dr. K at MIRCE Academy, where we're trying to bring the reality and the theory together. And in that way, what I mean by is, in theory, we have mechanical engineers who are trained highly for years and years to design and produce machines to do a job. But the bit they miss on the reliability side is they never get to see a failure, they never get to see a bearing failed, smell a failure, see the effects of a failure. So they can't have that within their data to build a better machine and loop around to eliminate the defect. So what we're doing is we're bringing the reality, what we see, and the theory together, and that's what I've been working with Dr. K at the MIRCE Academy. There are 2 previous case studies to this. And they can be found on the link either on my blog or on the RMS website. The first case study was an electrical motor terminal defect. On this one, we highlighted using additional technologies, and is where vibration analysis detected a poor connection. The second case study was on a standby fan motor, highlighting the need for correct storage of assets, rotation of assets, as a false Brillouin defect. And this third case study is another electrical issue, but it's a very, very interesting one. And we've only come across a few like this before, so I thought it's definitely one we should be highlighting. A bit about the history. So this is a routine site we go to regularly. Electrical thermal imaging, a bit of mechanical thermal, but it's mainly vibration analysis on the mechanical plan. On the routine survey, we noticed a change in the vibration pattern, not necessarily amplitude, but there's a distinct change in the pattern. So we use thermography to check out the motor, and usually there is a temperature difference as the seasons change, but on this day we can actually see a 10 degrees difference in the motor stators. So 4-pole motor, 1500 RPM on 50 Hertz line frequency. It's 2 motors driving 2 epicycle gearboxes, exactly the same, driving 2 rollers, crushing the product. They're both under the same torque, tension, load, and stress. So on the survey, we noticed this difference and vibration analysis, and then through thermography as well. And from that, we decided to alert the plant electrical engineer, and we advised a full electrical inspection prior to any failure. This is a vibration data, and down the bottom here is the historical data where you can see the 2 times line frequency. And on this particular survey, suddenly we had an appear of a 1 times line frequency, a 25 Hertz, which is really abnormal. And this is actually the peak view data. So comparing the velocity, the normal velocity, actually the levels came down. But this was what you normally would see, the 2 times line frequency, whether that's from eccentric, a difference in the air gap, how it's being torqued down, or just natural motion. On this survey, we had a lot of increase of 25 Hertz, and the electrical mount was now actually sidebanded by 25 Hertz. So the vibration had increased, but there's a change in the pattern and the condition. So we used thermography, and what was noticed was here on this data there, but comparing the 2 motors, you can see we're up to 75 and we're 63. And part of that data, it's a 4-pole motor, says 4 north and south, so 4 sort of coil packs. Well, one of them was warmer, so we're thinking we've got an electrical defect. Some are getting warmer, and the vibration was telling us that there's a different pulse, different electrical motion. So from that, the chap did an electrical investigation, and this is what he actually found. So here is a current trace, and this orange plot there is actually a varying current on this motor. And when you look to the 3 single phases here, you could see there's only half a cycle. So on one of the phases to the motor, on the 3 phase, there's only half a cycle. And comparing the 2 sine waves there, you can see a full cycle and the blue line a half a cycle. So we're thinking that is why we were getting warmer on one of the coil packs as such, and why we suddenly saw this 25 hertz. The motor wasn't happy. He did some interrogation on the drive and found out it was the IVI card. Now, we're not hugely electrical instrument people, but we saw a defect and we asked them to follow up. So the IVI card is basically linked to the IGBT, which is the insulated gate bipolar transistor. So this is part of the drive which creates the pulse width modulation, which is a pulse in the switching, really fast switch in the drive. And obviously this component was starting to fail. Now, it had only been picked up when we saw a slight change in the vibration pattern, and we checked with thermography. If we left this could have caused a lot of damage to the actual motor. So it was a really good find in that we've found the signal of a defect and it is rectified. So when we're talking about failure cause mechanism, we're thinking, well, it's electrical. It's just one of those failures, but it was a really old drive. It's been there for a while, so it's more classed as an age-related fatigue end of life. The mechanism of failure, electrical breakdown, electrical fatigue. The failure mode, how we detected it, was through vibration and a thermal pattern. So in summary, change in the vibration pattern and the thermography initiated further investigation. So it detected a sort of hidden electrical failure. So again, a negative functionability event where secondary damage could have occurred, which then would have cost production, could have caused a motor winding to a burnout, was averted. And in a controlled manner, they changed the IVI card and it's up back and running. So that's another good example of finding the defect, investigating, using more than one technology and fixing the problem. So how can we help you? Well, we're very passionate about knowledge sharing, which is why RMS Reliability Training Institute, we deliver training which is conform with ISO 18436. That's Mobius training, so you can get the MIBOC or the BRT certification. We have contract reliability services to help you out. If you want to do practical upskilling people on site, we can help you with that as well. And again, I do like this slide because lots of people talk about condition monitoring, vibration analysis. Yes, 90% of it is vibration analysis, but there are other technologies which we should be using together. So this is the technologies: vibration analysis, lubrication, thermography, and ultrasound. The main failure modes they can detect and how they're sort of all interlinked, and we should be using them all together. Again, this is a slide just about JPS Reliability, where we're registered, the book we published, and please, as I said before, look at the MIRCE Academy website and get in contact with the doctor because it's very, very enlightening. Thank you very much for listening to this presentation. We have 2 more to go, so hopefully you'll tune in.